So multi-body design, I think it's incredibly useful, incredibly powerful, and there are some really good workflows and reasons to use multi-bodies all over the place. So the reason I had a cake on the other side saying happy birthday multi-bodies is because they're actually 10 years old this year, I guess. They're born in 2003, so we could all sing happy birthday for multi-bodies a little later. But initially, the bridging technique, you don't even hear of the bridging technique. I read about it, and I was like, what the heck is it? It's just a simple concept of, like, for that golf club head, you make the golf club head, you make the shaft, you know where those two items are. Creating the loft in between those two by selecting those two inside faces is incredibly easy. Before 2003, you couldn't even do that. You needed to build your way from the shaft to that transition to the head, and that's just something that we all take for granted now because multi-bodies exist. So my definition of multi-bodies is the ability to model multiple chunks of geometry within the same part file. All right, so not too technical, but that's it in a nutshell. The items that we're going to be covering today range all over the place. Okay, so I actually tried to make a multi-body tab to my command manager. I thought it might be helpful, but I ended up putting like every single feature on it because multi-bodies apply to everything. So it doesn't really, narrow down to just a few industries. So about me, normally what I do if I'm presenting, the best part about presenting is answering questions. I often say, just shout out. Don't even bother raising your hand or anything like that, but I'm just a little worried about time because I got a lot of stuff to do or cover. So we could have a Q&A session out in the hallway if we really need to. But I've got a few years of experience on CAD, multiple platforms. Currently, I'm an elite application engineer for 3D Vision Technologies. I'm out of the Cleveland area. 3D Vision Technologies is a VAR that covers the Ohio, Kentucky, and Indiana territories. And the elite part is just, that means I'm a big-time nerd because I've taken a lot of the certification classes. Although, those things are pretty awesome. Especially today, I was excited to see that you can link your LinkedIn profile to it. I thought that was nice. All right, so the industries that multi-bodies can be used in. The first three listed, actually, SolidWorks forces you to use the multi-body modeling environment. So we should probably take a hint from SolidWorks as to why they're doing that. It's actually a very, very great environment for in-context design where one chunk of material needs to reference another chunk, part, component, whatever it might be. So weldment, sheet metal, mold design are all things that SolidWorks says, hey, the best environment to use is to model all this stuff into a single part file. All right? We're going to cover how the relationships are very, very tight. But there's other industries too. People making tooling or fixturing for around a part file. That's a great time or place to use multi-body design. Plate design or panel design, stuff with uniform thickness. Like a cabinet, we'll be modeling that and working through a couple of scenarios, introducing you to these things called cut lists and other tricks. And then furniture design is also good. And the continuing theme between all these types of industries is just that they're all static assemblies. They don't really have moving components. There are a bunch of components, but there's not like a dynamic door swinging or an arm rotating. Everything's just static and staying where it is. All right? So we're going to start off just covering the basics, make sure we're all on the same page on how to create a multi-body part file. And that is, we could just create two separate features. If we create those as two separate extrude features, they don't intersect, we're going to have two solid bodies. I'm sure you've all have probably run into that, or at least can imagine right now. The other option is, what happens when two bodies overlap and intersect one another? Typically what always happens is they get merged together into a single body. All right? And that just is something that happens without us even thinking about it. The reason, though, behind it is that little highlighted checkbox, merge result. That's on all the time. If we don't check it off, then that's how SolidWorks is going to react all the time, is it's going to merge all of our features into one solid body. But we can choose to uncheck that whenever we want. And in that case, if we do, those two solid bodies right there will stay two separate solid bodies. And they'll just interfere with one another. The little trick here that a lot of people don't know is if you want to work in an environment where that merge result checkbox is off all the time, then you could just insert a weldment feature. There's a button. It looks like it does nothing. It just adds a feature to your feature tree. But that's actually turning off that merge result option by default all the time for the rest of your modeling experience within that part file. So one of the most popular features in multi-body design is the combine feature. All right, it runs Boolean operations on multiple bodies. So we start off with a yellow and a green body. It has three modes that we could use that in. We could add those two together, so it is basically like turning that merge result checkbox on. We can subtract the green body from the yellow or vice versa. But what that does is it consumes that green body when I do that. And I'm going to show you a better way that we can remove interference without actually losing the body that was interfering with the other. But nevertheless, the combine feature, that's a subtract mode. And the final mode is the common mode, all right, where it just keeps the overlapping volumes. So this tool was very, very popular. And I'm going to show you how I barely ever use this tool anymore. The two tools that I use in place of this now are the brand new intersect command, which is available in 2013, and the indent command as well. Okay? The one place that I do still use the combine feature is for like modeling negative space. Sometimes it's just easier, more visual, to model the voids as solid geometry rather than starting off with a block and making a bunch of cuts to it. It's just easier to see. You don't have to worry about cutting a bunch of section views. So what you could do is you can model up the ports of this manifold and then model a block around it. Don't merge those bodies together. So at that point, we have three solid bodies in our part file, and then subtract the orange from the gray body. Okay? And we're left with our manifold. Another really good scenario for solid bodies is mirroring for symmetry. I always say when I teach the essentials class, when we do a linear pattern or any kind of patterning, including mirroring, it's more than just a time saver, it's actually a quality check, right? Because it's not only saving us the time of only having to create half of it rather than both halves, but it's always making sure that the second half is the exact same as the first half. It's our quality check. So I just want to show you this really quick. On this model, what I have here is a bunch of features, okay? And I have a solid bodies folder up here. Now, typically you wouldn't see the solid bodies folder. I'm going to go up into the options menu and select the feature tree or feature manager. And two settings that I highly recommend is to show always, so set it to show rather than automatic, solid bodies and surface bodies, those two folders. It's good to see them at all times. And typically, if you have it on automatic, which is the default, it's not going to show that folder unless there's more than one of those types of bodies. So here what I could do is a little bit of another tip is if you right-click on the solid bodies folder and hit Show Feature History, you can see all the features that are related to that particular body. This becomes a lot more useful when we have multiple bodies inside a file. Right now we just have one. One solid chunk of material is made up of all those individual features. So in this case, it's kind of like a shortcut. If I go ahead and mirror, fire up the mirror command, select that face to mirror about, and rather than selecting all those features from the feature tree, much quicker is we could just specify that body. Click right there. It grabs all of those, and we go ahead and mirror that over to the other side. Now the cool thing is, for updating purposes, if I were to create a feature right here and say extrude that up, the feature doesn't get automatically mirrored over, but that's because it's all time dependent, right? So we had this chunk of material, we mirrored it, and then we added that new feature. But what's cool about that, because it's not dependent on the features, I could just drag that new feature up above that mirror feature, and it gets mirrored over as well. All right? So it's a time-dependent command that is looking at this solid chunk of material at that point in time and mirroring it all over to the other side. So it's kind of more intuitive than mirroring all the features, and a lot less updating to go along with it. This is another trick that I'm going to show you. With weldments, there's going to be a lot of presentations here, even throughout the tomorrow and the rest of the day today, on weldments and sheet metal design specifically. I'm going to show you some of my favorite tricks with those, but I'm going to focus on multi-bodies and some more unique applications for the rest of the time after these few tricks. So my first one is a super easy 3D sketch. All right, 3D sketches are not fun. You don't have to be ashamed of not liking 3D sketches. There's so many more relationships that don't exist in 2D sketches. There's some that in 2D sketches that don't exist in 3D. It's just not a comfortable environment, all right? But we can all go ahead and create that geometry, right? Extrude up like that pentagon shape, start a sketch on the top, convert the entities, extrude it up with draft, 2 features, and we're done. Start up a 3D sketch, a new feature that was added a couple years ago. If you click one edge and hit Control-A, it's going to highlight all the other edges in the model. And then what you could do in that 3D sketch is hit Convert Entities. So now it converted all the edges from our solid model, our solid body, into that 3D sketch. And now we could use that to go ahead and create a weldment structure in the shape of that original solid body. All right, so I want to just show you the results of this really quick, because the benefit of that is, here it is, this original solid body, created the 3D sketch, and what I did after that is I have this solid body that I don't really need. If you just select it and hit the delete key, what it does is it fires up this feature right here, the delete body command. It gets rid of that body. It's a time-dependent thing, all right? So it's kind of like a sacrificial solid body that we only needed to create the 3D sketch. Once we're done with the 3D sketch, we get rid of it. And then I create my structural members along each one of those paths. The cool thing is if I click on this feature, if I have Instant 3D on, we're going to see all the dimensions. I can just drag those around. If I change the extrusion, it's going to change the converted entities, which is going to change the weldment profiles or structural members that go around it. All right, so any one of these angles, I could just grab on those blue dots and edit it around, and that becomes an extremely easy way to modify that 3D sketch. Okay? Mold design, you're going to find a lot of presentations that go into a lot of detail about that as well. Very niche market. But SolidWorks has some great surfacing tools that are automatically built to build the tooling around, a plastic part, and extremely powerful multi-body tools. All right, the tooling split that creates the top and bottom dies, or the core and the cavity, around that geometry. And there's plenty more. The core tooling and all that is all multi-body design. Now, sheet metal is something else that's multi-body. Just over the past couple of years. But what I call this trick is convert to plate. There is a feature called convert to sheet metal, okay? And we could take a solid body, just like I did with the weldments, and create sheet metal features from that. If I hit convert to sheet metal, I could select a face and start selecting a bunch of other edges to wrap that sheet metal part around the solid body, kind of like wrapping paper, okay? But a lot of people don't realize that they could just use it for plate design as well. You could select one face and then another face and then another convert to sheet metal. And while we're doing that, there's a little checkbox called Keep Body On. And I can keep that solid body to continually reference all the other faces until my final one that I reference, I could turn that checkbox off. And now my body's gone. And again, I have a plate design that's all based on a very simple extrusion feature, a solid body that can be changed at any time. I could show you guys this, but I'm going to move on to some more examples first. So one of the big things I've noticed over the lifespan of multi-bodies in SolidWorks is every single enhancement since 2003, and you can see that SolidWorks is invested into this technology, into this environment. They're adding features and functionality to the multi-body realm every single year up until 2013. So it's a great environment, and it's something that everyone should be at least considering, which is what this presentation is all about. But you can see how everything that's been added is functionality that exists inside of an assembly. All right? So the line between assembly modeling and multi-body part modeling is thinning every year. I'm not saying throw away your assembly files, okay? There's actually a presentation coming up after this one I saw that's assembly models versus multi-body models. So if you like this stuff I'm presenting on this kind of comparison, then that's probably going to be a more thorough explanation as well. The main difference, though, summarizing the differences, is that assembly models are dynamic and multi-body parts are static. Okay? So if you have moving components and you want to see those degrees of freedom with those mates and all that, you need to use an assembly. All right? There's absolutely no comparison. Multi-body parts, where you leave that part, that's where it's going to stay until you physically use a feature to move it. Multi-bodies require no external references. Now this is a huge benefit. All right? Everything's contained within a single file. But with that great benefit comes some disadvantages as well. With everything being in just one file, it presents some data management issues. You know, how do we assign, how do we revision manage an individual body inside of a part file with data management software? It gets a little bit tricky, all right? It also makes the process of creating a drawing for an individual body a little bit, it's not, I was exaggerating when I said hard, it's just a couple extra clicks, but there are some more steps required to do some other things. But here's a visual way to compare the two states, is that the chain of relationships, when you're defining, and who here is doing like in-context assembly design? Okay, so you guys are definitely going to want to consider this depending on the types of products or assemblies that you're making. Because this is what you have to deal with in-context assembly design. You got the in-place mate. You're creating a feature that's inserted into a part that's relying on the assembly file, that's dependent on all these other parts around it, offset from it or dimension to it, coincident to it, and then all those parts are dependent on the mates that are locating them all, and they may or may not be dynamic. So there's all these things that can get twisted and kind of confused or broken because there's a lot of links to that chain, right? And that's just more places for it to break. Inside of a part file, whether it's multi-body or single body, it's the same thing. We got all of our features in a part file, and the chain is very short. Okay? So now we're going to get into modeling some things. This is one of my favorite little tricks, and that is for creating an assembly. Say you're making something out of panels, plate design as well, and you want to continually reference a uniform thickness. You know, the example that we're going to use is we're going to make a cabinet 3/4 of an inch thick stock material. All right. Now, there's a trick here that you can insert a sheet metal feature and then delete it. Delete that body. So you're tricking SolidWorks into thinking your part file is a sheet metal part file. The benefit of that is when we have a sheet metal part file, we have this little check mark called link to thickness. Okay? That becomes activated when SolidWorks thinks you have a sheet metal part file. Now, rather than saying that if I make a panel, draw the perimeter of it, and extrude it, saying it's 3/4 of an inch long, I don't have to continually do that. I just check link to thickness, link to thickness, link to thickness. All right? If I don't want all those bodies to merge together, because I want each panel to be its separate piece, I insert a weldment feature. So I'm going to show you guys this. And then if I ever change my mind, I want to change to a 1/2 inch plate or 1/2 inch material rather than 3/4 inch, I just edit one feature and edit the thickness of that sheet metal feature, and it is updated across the board to all my panels or plates. Okay, so let's take a look at this. You can certainly create a template of this guy so that these features are automatically already inserted for you. So what I did was I inserted a base flange, just drew a rectangle and created a base flange feature on the sheet metal tab. Then I deleted it, selecting that body, hitting the delete key, and hitting enter. And now I also inserted a weldment feature, and that is on the weldments tab, this button right here. It's grayed out. You can only insert one weldment feature. It just sits right there. You think it doesn't do anything, but I'll show you what it does in just a second. I'm going to start a sketch on this top plane. Just draw out a rectangle. So I'm going to draw the bottom panel of my cabinet. Make that 20 inches wide, say 12 inches deep. And I'm going to extrude this upwards. And right now, I could type in 0.75, but instead, much easier, just check link to thickness, and it knows that that very first base flange was 3/4 of an inch. So it's going to make this feature 3/4 of an inch tall, or thick. I'm going to start another sketch on the side face. And I'm going to draw another rectangle, maybe a 3-point rectangle, so I could start out at these bottom corners. And that way all I have to do is define the height. I'm going to extrude that rectangle out, and again, link to thickness. You'll also notice that that merge result checkbox was automatically off. That was from the weldment feature. Okay? Normally that's always on if we don't have a weldment feature in our feature tree. I'm going to hit OK, and now we'll see that we have now built two separate solid bodies. They have not merged together into one continuous chunk of material. All right, so I'm going to throw this in the oven and let it bake for a minute. And open it up right here. And we'll just browse through this feature tree to see the rest of the things I did. I went ahead and created a base flange. That was an actual sheet metal part, so that's flattenable if I right-click and flatten that, even though it's got the wood material right now. SolidWorks doesn't know that. I mirrored that bottom panel up, mirrored the side panel across, mirrored that base flange. I created a rectangular sketch on the front face and actually created a structural member feature. So this is how weldments work, all right? They take a profile and they're like an automated sweep feature that works in the multi-body environment so that each one of those bodies is independent as they would be manufactured in real life, okay? Again, a lot more presentations specified on just sheet metal and weldments that you could check out all over the place here. All right, I created a little glass panel, a back panel, and then what I did was I inserted these indent features, and I'll show you what these are doing. If I select that one, and select that one, you'll see that it's highlighting the little edge that surrounds that glass panel right there. If I right-click on a body, I could select from the right-click menu, Isolate. And what's actually going on here is there's a cut inside of this frame body, okay? That happens to be the exact same size so that that panel can fit inside of it. I did that with the indent feature, and I'll show you how that works. But before I do that, I'm missing one more indent feature. And if I didn't know that, here's how I'd check. I'd check for interference. Unfortunately, though, interference detection is a feature that's only available in assemblies, okay? So what's the workaround? I'm going to insert this file into an assembly. Just plop that in. It doesn't matter where it's located. Where'd it go? There it is. Okay, and I'm going to select interference detection. There's a checkbox on the interference detection option, property manager, that says include multi-body part interferences. If I check this on and hit OK, oh gosh, check this on and hit calculate, it's going to show me the interference between the bodies within that part file. Okay? So far, I mean, the modeling process of this cabinet is really simple. Just rectangles and extrusions, length to thickness. All right, a simple sheet metal part. Check for interference. The indent feature that I want to show you works like this. I'm going to select these two bodies and right-click and hit isolate. And you can tell that they're intersecting because we don't see that black model edge right there. So that's the easiest way to detect for interference, if you can notice it. And all I'm going to do is fire up the indent feature. This is the body that I want to cut away from, so the target body. And this is the body that I want to do the cutting with. And I want to cut with it, so I'm going to turn on cut. So all this does is remove the intersecting geometry from the target body. Very, very simple. And if that original body ever moves, then it's going to continually remove enough material so that it could fit in there perfectly snug. All right. In an assembly? Nope. You could give clearance. Yeah, we'll take a look at that. All right. So what's going on here now is there is something called a cut list being built. All right. So right up there. That's similar to a bill of material inside of an assembly file, okay? It's a list of all the bodies that exist inside of this single part file, okay? And with those, question? Depends. It's feature tree dependent, so everything's time dependent. If you rename it, then you add some features and switch it around, it has a chance of being renamed. But what doesn't get renamed are the folders that I'm about to show you. So what we have here is a list of bodies, okay? The cut list, and notice that the solid body folder got renamed cut list. That's because a weldment feature is in there. So a cut list adds a little bit more functionality than just the solid bodies folder. What it does is it allows you to add properties to bodies just like we could add custom properties to part files. Okay? And I'm going to show you how to do that. So if I right-click this cut list folder, it's kind of like semi-automatic as far as the organization goes. You have to hit update when you want it to be updated. So it's, semi-automatic. As soon as you do that, what it's going to do is it's going to find all the like bodies. It's highlighting the bottom panel and the top panel and grouping those into a folder. So the two sheet metal tabs or brackets has been combined into a single folder. So this is SolidWorks' way, just like a bill of material finds like part files, SolidWorks is finding exact same or identical bodies and grouping them. We can name these however we want. So if I select this and call this a glass panel, just like I've already done for the first few folders, we could keep organized by just giving that a name. All right. I could also, if I expand this open, right-click and apply a unique material to each body. This is another recent enhancement. So if I wanted this to be glass, it's as simple as that. Mass properties update, all that, just like an assembly file. The sheet metal tabs in the back, it's killing me that those are still wooden. So I'm going to right-click on just one. I could right-click on both and update both individually, or at the same time, I'm sorry. But I'm just going to update one individually. And let's give it 304. But what you'll notice is as soon as we add a separate material or different material to one, they are no longer grouped together. There's a new cut list item made for the second. Because it's not only analyzing that it's the same geometry, but that every single property of that body is the same as well. Okay? If they're made of different material, they're not going to be the same. So if I right-click on this body and change that material, it groups them back into the same folder again. Okay? So it's just a little folder organization of all of our bodies. And if I go ahead and open up the part file, or the drawing file for this, you'll also notice that we can create exploded views for bodies. Same exact method as creating an exploded view for an assembly file. You can insert those directly from the view palette into a drawing. And what I'm going to do is insert a weldment cut list. So I'm going to bring up my tables list. Rather than clicking bill of materials, I'm going to insert a cut list. And I'll just use my default template and pop it in right there. Okay? You'll see what it's automatically doing. It has the cut list name as one of the columns. That's pulling from the folder names I just gave it. A description property and a length. Now for items number 6 and 7, those were features created from the weldment structural member. And if you guys haven't noticed too, that was a 1x3 piece of hardwood lumber. I have a lumber weldment profile library. If you want it, just, well, on the screen is my Twitter. You could tweet me or email me. I'll give you my email at the end, and I could send that over to you. If you like to do home projects, building decks, things like that on the side. All right, so the weldment property, I'm going to come back over to the part file. And if I click on one of these weldment icons, you can tell which have been made with structural members because they receive a special icon, just like you could tell which are sheet metal bodies. If I right-click and I hit Properties, you're going to see the properties that are attached to it. Similar interface as the custom properties for a part file. Automatically, when you create a structural member, it adds a length property and an angle 1 and angle 2. Those angles are the angles that are being cut or mitered at either end of the structural member. So it gives you the overall length and the angles that you need to cut automatically. The next 3, stock size, material description, those were all custom properties that were added to the weldment profile document that I referenced for that 1x3 piece of wood. Those weldment profiles are just a big folder of sketches with an SLD, FLP, or LFP, I think, file extension. You look in there and you'll see. So all that stuff is automatically taken care of for us, right? If we look at the bracket, I could click on it right over here now. You can see that all kinds of properties are automatically added to the sheet metal bodies. This stuff is what makes SolidWorks costing possible. It finds out the overall cutting length around the perimeter, the inside cuts. You could track the overall linear length and your laser cutting speed and figure out a total time for cutting that out on your laser cutter, that blank of the sheet metal part. All kinds of information. The problem is these little manila folders were just extrusions, regular features. I right-click on one and hit Properties, and bummer, there's nothing. There's a material, that's nice, but nothing else, right? No overall size. In 2013, one of my favorite enhancements, because obviously I like multi-body design, if you right-click, what we used to do, just to show you the hard way, is I used to create like a length, a width, a height, and then in this field you can click, show your annotations, and click on a dimension, and it will be linked to that dimension. That was a way to do it, but it's very manual, and imagine you're making a huge staircase or something like that. You'd have to do that for every single one. This is extremely easy. You just right-click and hit Create Bounding Box. Again, this is only available in 2013. You can mass update these by control selecting them and hit Create Bounding Box. And what we'll see is when I right-click and hit Properties here, it adds all kinds of properties: thickness, width, length, volume, and a description that combines all of them into one nice, easy, simple description. So right-click, Create Bounding Box, and now no matter what kind of feature, sheet metal, weldment, if you didn't use one of those two and you use just extrusions, revolves, cuts, who knows, it's going to be able to find that. And the way it does that is it creates a little 3D bounding box. Let me pick a body that's easier to see. It might be hard to see, but it's showing you a bounding box, a 3D sketch that was sketched around the perimeter of that geometry. So even if it was like an organic shape, it would just draw the smallest 3D box around that it could. All right, I'm going to go ahead and come back over to the cut list, oops, which is in SolidWorks. And you'll see that those descriptions have been updated. So they made that job really, really easy for us. The other thing that I want to cover with drawings while we have one open is how do we create a view of just one? Because we are typically creating drawing views of entire part files. But what if I just want to show this side frame so I could detail the angles and the overall length myself without relying on this cut list table? Here's a trick. It's called a relative view. Okay? It's not on your toolbar by default, but if you just go ahead and search REL, there it is, relative view. So I'm going to fire it up. I'm going to select this view, and it takes me to the part file that was linked to that view. Here what I could do is I could specify that I want to create a view of just a specific body. I'm going to pick that one. Now I could specify what the front face is, so I could even orient it in my drawing by saying that is the top face. So I specified the front and the top face. If I hit OK, it brings me back to the drawing environment, and it filters to just that body, and now I could throw on my dimensions for that. I could do that for each one of my bodies, put them on separate sheets, whatever you need to do. Another way is for sheet metal parts. Okay, it's a little bit different. You're going to want to use a model view tool. If I select this, and it's a multi-page property manager, so I'm going to click over to the next page, we have this option now to select the body that we want to create a model view of. So I'm going to select the body. I'm going to select that sheet metal body. So since it's in the part, I'll just select it from the feature tree. And I'll plop it right over here. What we can do, though, with the sheet metal part, the important thing is to show the flat pattern. So I could just switch over to the flat pattern view from this list, and it's going to go ahead and show me that. I could change the scale, and there's a flat pattern for an individual body within a part file. Okay? So this is all summarized. Let me go ahead and close this out. Oops. Control. Oh man, I'm getting confused with all my keyboard shortcuts. This is all summarized over here. I'm going to cover these steps. If you want to, this is something to come back and reference. These are ways to kind of hide bodies, show bodies, right-click mouse button tricks throughout all the different environments. The other thing I want to share with you about a cut list, the second bullet point here, is what if we wanted to add the same property to all the bodies in my part file, mass update them. A little unknown trick to a lot of people is you could right-click the weldment feature in your feature tree that gets popped right at the top of it. Right-click that and hit Properties, type in a property, and it's going to add that to every single body inside of your entire part file. So if you had like a vendor property or something like that. So we covered all these items, but this is for you to reference later if you'd like. And the other thing to know about that bounding box is that if you have an organic shape, it's just drawing a box around it. Maybe you want it to be rotated a little bit. You can right-click and edit that bounding box and select a face to realign it or position it to your geometry, which is useful. Creating the individual or drawing views that are specified for a specific, a unique or just one body. Two other options are to create configurations where all the other bodies are suppressed except for that one and activate that configuration, or display state where all the other bodies are hidden except for that one. All right. Now, some other tricks. Who deals with purchased components? All right, assemblies, some of them? Okay, so most of the time when we bring in a purchased component, we don't need all the detail that comes with it, right? And we don't want that taxing our assembly performance, our hardware. So a common trick that we used for a long time was to save an assembly as a part file. It's simple. You just select the Save As type as part rather than assembly. All right? What it's going to do then is it's going to convert that multi-component assembly file into a multi-body part file. Now the file management gets really simple. We could just assign it a part number and it'll just be one file rather than a bunch. And we can insert it into any of our assemblies. The cool thing too is that if you look at that quote down at the bottom, when you hit mass properties of that part file that was previously an assembly file, it's using the mass properties from that assembly file. So it's not updating if you make changes to that solid body. So that means I could go ahead and delete all the components that I don't want to keep. You know, there's just additional faces and features that are taking up SolidWorks calculation time. So I can make any changes I want to simplify that geometry, and it's still going to remember the same mass properties from the original assembly it was created from. But since then, there have been a few new features. D-feature, which is a great way to simplify geometry. You could use that on assemblies or part files, and also the speed pack. That's not really multi-body stuff, but I'm just sharing it with you. All right? A speed pack, you can actually open up in a sub-assembly, super, super lightweight, with only SolidWorks loading a few faces for mating purposes into another assembly. Now, this is the string of the rest of the examples that I'm going to show you today. And that is the master model technique. This is one of the most powerful and most useful methods of generating a part that's eventually going to be an assembly inside of the part mode. So for example, how do you think these guys manufactured or designed this mouse? Right? It's got contours all over, and all the pieces and parts come together to form a really nice final shape. They didn't go ahead and create the left click button. They didn't go ahead and create the right click button all in separate part files, the side grip in a separate part file. They did it all by creating one single body chunk of material that represented the final shape that they wanted to get at, and then they split that into separate solid bodies, which then they could export into individual part files for manufacturing and detailing. Okay? So this is a process that I'm going to demonstrate on this Wii controller, all right, that I downloaded from GrabCAD. So we could take this overall shape that we want, you know, to fit in the palm of our hands, and then start building all the features around it. And again, this is to demonstrate that multi-body design, because of those chain of relationships, is the ultimate environment for in-context design. You don't have to worry about mates breaking. You don't have to worry about parts being swapped out for other parts. It's all features, just like we're used to when we make any other part file. All right? It's just that we're separating those features so that they're different chunks of material within that part file. So creating the buttons so that they follow the same curvature as a face, creating a nice little grip, like a rubber grip to go around that handle portion, creating a snap-in panel to maybe for batteries or whatnot. And what we'll also find out is that we could also insert a part file into a part file. So talk about being like assemblies, inserting parts into assemblies, we could do the same with part files as well. And that part file will always reference the part file that was inserted into it, okay? So let me show you some of this. How are we doing on time? 45 minutes, I got 15 minutes left. Whew, gotta hurry up. All right, let's open up this part file. So yeah, I mentioned GrabCAD. Everybody's heard of 3D Content Central. That's a great place to go and get CAD files. Another place that's emerged over the past couple of years is GrabCAD. It's basically just like 3D Content Central has users that can submit CAD data. This is users of all kinds of CAD backgrounds. It was actually started by some Solid Edge guys, and a funny story is that they sent out an email 1 year after the site was launched, and it had a bar chart of all the different CAD packages, separated out how many files were uploaded per CAD package. And again, this was started by someone from Solid Edge, and SolidWorks was like way up here. The rest of the things you could barely see. They're like tiny little pebbles. So that speaks to our 2 million users, I guess. Very active. So Jason T, whoever that is, he kind of looks funny with that mask on, but I got to give him props for letting me use this model. So he had it completely finished. I took it back and just made it a solid chunk of material so that it would be a start part or a starting position for this example. So I'm going to walk through these features rather than create them from scratch. But what I did here was I created a revolve feature from this sketch. So multiple contours, multiple enclosed contours revolved at the same time is going to create multiple bodies. And right now I have 3 bodies created. So why didn't this guy merge with that guy? It's because I went in and unchecked merge result, so that I kept those 2 bodies separated. I then created a cut. And what we'll see here is that cut away from this body and that body, but not this body. The way I created that cut is if we take a look at the side here, I just drew a rectangle and cut through there. If I edit the feature, we'll see something very, very important called the feature scope all the way down here. This doesn't pop up unless you have multiple bodies. And what I did was I specified which bodies, those 2 highlighted blue bodies, that I wanted to cut through. Okay? And I didn't select that overall handle body so that it was ignored with that feature. So localizing features is a huge benefit. This is a great example too in the stolen from the advanced part manual, that we want to go ahead and add a fillet to that angled face, that top edge. If we do that all as one solid chunk of material, we're never going to be able to blend that well in the corner. But if we imagine that we broke those 2 sections into that yellow section and the green section, and imagine that the yellow section wasn't even there, it's really easy to fillet that top edge, right? So what we could do is we could keep those separate bodies, add our fillets to the separate bodies individually, then just merge them together with the combined feature afterwards. All right? So separating bodies allows us to focus our features on independent bodies as we go through our design, which is very, very powerful. All right, so moving on. A really simple feature, the loft command. Some people are intimidated by it, but it's extremely easy if you're modeling between 2 separate faces. You just click on one face, click on the other face, and it's going to create a loft in between those. And you have some blending options for making them tangent to the surrounding faces and whatnot. This one was a revolve cut. All right? I don't know why my graphics card is adding those little jagged marks. But again, this is in context design. I'm not giving that a diameter or anything like that. I'm just saying that that cut is going to have to fit in that joystick part, so it's going to be offset by a specific distance. I don't need to know what the diameter is, right? So that way, when the joystick changes, the cut will change, and they'll always fit together perfectly. Add a couple of buttons, just simple extrusion features. But what this allows me to do is offset from that curved surface to make sure that it follows the exact same contour as the surrounding geometry. All right, more in context. This stuff is really hard to do inside of an assembly, referencing between that part file and managing those external references. The indent feature. So right now what we have are these bodies intersecting the main handle body, right? They're overlapping, they're interfering. The indent feature that I showed you before, this is a little bit more visual now. If we take a look at that, somebody asked about clearance. So what it's doing is it's removing the common geometry between the 2. And right here, I can insert a clearance value as well, so it offsets while it cuts. So also very, very powerful. I'm now going to create a sweep feature, maybe to add a little trigger that actually forms to your finger. Cap that off with a dome feature at the end. This stuff isn't too important, but here's the main part. What I have here, as I'm creating this bottom little trigger body, it's actually broken up into 1, 2, 3 bodies at this point. And I'm going to have to merge them all together because that's going to be one component of my controller. The other problem, too, is that I have this big little slice in there of void of geometry where I'm going to have to fill that in. A real cool trick, a surfacing trick, is the surface extrude. What I could do is I could right-click and hit Select Tangency and hit Extrude Surface. It's available on the Surfacing tab right here. It's the very first feature. And what that's going to allow me to do is extend a surface that follows the perimeter of those faces outwards. What I just did was I bounded all those bodies and that little sliver where there's that void of geometry. With the intersect feature that I'll show you in detail in a little bit, what it does is it takes all those bodies and that surface, combines them all together, and fills in the voids, all in one shot. Okay, so very, very powerful multi-body command using both solid bodies and surface bodies. All right, I'm going to shell this out, and then I'm going to go ahead and mirror this across. And I wish this was a 90-minute presentation rather than a 60-minute presentation. All right, so something I'm going to show you really quick is one more feature that I could have added. I covered this feature inside of the surfacing presentation. Who, by the way, attended that surfacing presentation? Okay, nice to see you all again. So the copy surface command allows me, well, the split line, the copy surface, you all saw that. What I could do is I could split this geometry into multiple faces that I could select and copy, and I could take that surface that I copied from those faces and thicken it. That's a great way to create a feature that, I mean, how would we do that otherwise? We'd have to extrude normal to the face of all that, you know, all those curved faces. There's no way to do that but the thicken command, and that's a surfacing command. But the main thing I'm doing here is that's a thin-walled geometry part of the handle. And now we have this thickened body and the handle that is a thin body, and they're overlapping one another. So the indent feature, not only does it remove material when we have that checkbox on, but it will actually deform geometry as well. So what it does is it indents that geometry so it's recessed to fit the overlapping volume of that grip. Okay? Very powerful command. And there you're left with a grip that is perfectly insertable into that indented feature. So I want to talk about this. We have that master model, right? Now what are we going to do? We need to add so much more detail to each one of those part files. Maybe we need to shell them out because they're going to be injection molded. Maybe we need to add some ribs, all kinds of more detailed features to each one of those individual parts. So the master model technique allows us to build all those, their overall shape, in the environment that is easiest to do so, which is a part file with all those relationships. But then what we could do to add our finishing details is save those bodies inside of that part file to be parts, individual part files. And then we could insert those into an assembly file. Seems like a lot of extra work, but SolidWorks built in some really nice commands that allow us to do this in basically a couple of clicks. Okay? The one that I like to use a lot is a save bodies command. You can see it could do a few things that the insert into part or insert into new part feature cannot, and I'll show you both of those. It can create an assembly on the fly, and it's just one feature. Okay? So let me show you how this works. If I go ahead and come over here and say, you know what, I need to add a lot more detail to this specific body. If I click a body in the graphics area, it's going to highlight the feature that was last used to affect that body. And it's also going to highlight the body inside of the solid bodies or the cut list folder. If I right-click that, I can select Insert into New Part. If I do so, SolidWorks is going to ask me where do you want to save that. I'll just save it to my desktop. And what this allows me to do is have an individual part file that's completely dependent on the other part file, the master model. So if you have ever worked with in-context assembly designs, you know that this little arrow represents an external reference. Question back there? Good question. If you go to your open dialog and select a file that you want to open up, yeah? So it can't find the original file? If you've lost a link, like if a file's been renamed or anything like that, again, you could browse to the file that's referencing the other one and hit References. And because it's open right now, I can't do it, but it's going to list out all the files that it's referencing. At that screen, you can relink it to the file that you could browse to. We'll talk afterwards, okay? Maybe I misunderstood. But anyways, this is forever referencing it. This is the relationship right here, and I know it's 3:45 right now, so if you guys want to go, you can. If you want to stay, you can as well. It won't hurt my feelings. I am sorry for running over. But the relationship here, the important thing to understand is it's one directional, okay? Things that change in the master model, that original part file, are going to propagate to this part file, all right? But things done here are not going to propagate backwards, okay? That's all you need to know, and it's pretty simple from that point forward. So here we could shell this out, add ribs, add mounting bosses, whatever it might be, and finish off the part design, add our custom properties to this guy, and file manage it just like we would anything else. Let me come back to SolidWorks once more. Yeah, because this file could, the question was, do I normally add it to the separate files rather than this file? And the answer is yes, because SolidWorks is RAM dependent, and the more features, the more surfaces, all that you got going on in one file, it's going to start to slow down. So separating these out at a certain point, when you no longer need those references, like I don't need to know anything about these other bodies to add that shell feature. So those are the types of features I'd like to add elsewhere. The other thing that we could do is we could insert bodies into this body, as I mentioned. All right? What I'm first going to show you, though, is something new in 2013, the ability to insert multiple bodies into a multi-body part file. So I'm going to insert an actual feature just by dragging and dropping it from here, that little 3DS logo. It's going to ask me for a reference point, and it's going to plop it right into this part file. Those are just a group of features that I dragged and dropped into my design library because I wanted to reuse them. Okay? That's just design library stuff. But what I'm going to do is I'm going to come up here and actually delete that body. Get rid of it. You can see that I also brought in, with that feature, a whole feature as well. So as many features as you want, you can bring in. That's just the design library's standard functionality. But what I could also do, this from Windows Explorer, from my desktop, from wherever, I can drag a part file into another part file. It's going to ask me, do I want to make a derived part? I'm going to say yes. And I could just place that wherever I'd like. What you'll notice on the left-hand side of the screen, we can attach and also insert surface bodies, planes, which is very useful for locating purposes, and other types of items. We could break the link to the original part. And we could also, what I like to do is locate the part with the Move Copy Body feature. I'll show you what that means. Does everyone know what mate references are? If you're using assemblies, you got to be using mate references. If you have a standard library of components that you insert a lot, add a mate reference. It's on the reference geometry dropdown. Search it in the help file. Use it, because this is what it does. It automatically, notice how it aligns the face up to the face I'm hovering over, and even to the point where if I hover over a hole, it will insert that right into the hole. Okay, the mate references work with part files inserted into other part files as well. I'm just going to place it right here to show you that if we do need help locating this after the fact, what I could do is fire up the move copy bodies command. Let me show that. Looks like a little orange and green body. And I'm going to move this body, and the way that I'm going to move it, we have a few modes. I could translate it, just drag it up or down, any single body in my model. I could rotate it about an axis. Or I can flip over to this constraints, which is the mate environment. Very, very similar to assemblies. We see all the standard mates that we're used to. I'm going to go ahead and select that cylindrical face. And I'm going to select that cylindrical face. And it's going to go ahead and add a concentric mate. But that mate, again, remember, is not dynamic. I underdefine that, right? It should be able to spin around in there, but I can't. So that mate is just for locating purposes. That's something really important to understand. Again, multi-bodies are static. We put it there, it stays there until we move it. Okay? This guy now is a feature that is a part file inserted into this part file with a little arrow saying that it is always referencing that other part file. So that if that part file changes, this body inside of this part file is going to change. I have one last example. So if I covered this stuff too fast, which I'm scared I probably did, you could come back and there's some more thorough explanations of what exactly is going on here. But the final and another awesome place to use multi-body design for is fixturing or tooling design, where you need to build components around the exact geometry of another component. So you might be doing this in assembly, and that could be a really hard environment to work in sometimes, just because none of these components are going to move, and all those mates are just kind of overhead. It's more stuff than we should have to worry about. So what we do is we open up a blank part file. Then we insert the part file into that part file, the one that we want to reference, okay? Now, it's just there for reference. We start building around it. I look at the side, I draw out a side profile, maybe for like a little charging base for this handle. I extrude it out. I go ahead and add some finishing details, mirror it over, add some nice fillet features to get that final shape. And then, with one feature, the intersect feature, I'll show you how this works, can go ahead and remove the geometry from the handle from that base. Okay? So now your base is always going to perfectly fit the handle geometry. And if that handle ever changes, it's going to change the part file that was inserted to, which will update the geometry of that base. So let me show you this workflow really quick, and then I'll be done, and we'll leave it open to questions. So I'm going to close this guy and this guy. And open up this example. So here, yeah, I've got 3 solid bodies right now. The grip handle, the overall part file, and this base that I haven't finished modeling, so I'm just going to go ahead and mirror that over and select that entire solid body. And now what I'm going to do is I'm going to use the intersect feature, which is available on the surfacing one because I put it there, but if you can't find it, just search for it. And I'm going to select all the bodies to intersect. This is a really simple tool to use. It's actually a bunch of tools kind of wrapped up into one. I'm selecting all those bodies and I'm clicking intersect. SolidWorks right now is analyzing the relationships and the overlaps between all of those bodies. And again, this, you could have surfaces in here, you could have planes selected. It's going to split bodies apart. It's going to create volumes inside of completely enclosed volumes as well. So here is what we're left with, all these little regions. So you can see that we've got, when I highlight this, that's a solid body, that's a solid body, because this is the intersection between that portion of the handle or the Wii controller and the intersection between the base that I'm putting it in. So it splits it into all these little bodies, right? Which seems kind of overwhelming, but here's the real simple way to use it. All I want to keep are the bases, because what we're doing is we're specifying the regions that we want to get rid of. Fortunately, they put this button in, invert selection, so now I'm selecting all the other bodies besides the two that I want to keep, and I hit OK, and we're left with the two volumes at the bottom. It's merging those two together because that merge result checkbox is on. And now we have a base that is always dependent on that originating geometry, and it's going to fit just perfectly inside of there. Okay? Again, we have a little arrow so that if that body ever updates, that original part file, this will update as well. The final slide, I promise, another way, is to, if you want to find the internal volume, this is a super simple trick. With the intersect feature, just copy a plane, maybe offset the top plane, the height of the liquid inside of that bottle. You select the plane and the bottle and hit intersect. And by default, if you just hit OK, you're going to be left with the internal volume that's created from that. You have to just remove the body, the original container, or whatever it is, a dish soap container. You just need to remove those bodies, and then you're left with that. Then that's configurable. You can make a configuration where the intersect feature is either suppressed or unsuppressed. Now you have a configuration of the bottle, and you have a configuration of your internal volume, and you can assign different materials to each of those, get the mass properties and all that, the volume, and you're done. All right, so that's my email, that's my Twitter account. If you want to contact me with more questions, I'm really sorry that this went over. Next year, if I do it again, I'll do a 90. Thanks.